At 0830 hours on the morning of June 19th, 1944, Ensign Sakae Yamamoto stood on the flight deck of the carrier Taiho, watching American aircraft appear through the clouds over the Philippine Sea. He was 22 years old. He had been flying for 11 months. In 40 minutes, he would be dead, and the carrier beneath his feet would be at the bottom of the ocean. But at that moment, what terrified him more than the approaching enemy was a number he had seen in a classified briefing 3 days earlier. The Imperial Japanese Navy had entered the war with 10 fleet carriers. They now had 9 operational carriers in this battle. The Americans, according to intelligence estimates, had fielded 15 fleet carriers in this engagement alone, with dozens more in various stages of construction or working up. The number seemed impossible. Japan had been building carriers since the Washington Naval Treaty of 1922. The Americans had supposedly started later, built slower, had less experience. Yet somehow, in the middle of the Pacific, the American fleet had grown while the Japanese fleet had shrunk. Yamamoto did not understand how that was possible. Neither did his commanders. Neither, it turned out, did the men who had planned Japan's war strategy. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comment from where in the world you are watching from today. The question of how to build an aircraft carrier fast enough to matter in a war was not a question anyone had seriously asked before December 7th, 1941. Carriers were rare, expensive, technically complex vessels that took years to construct. The Washington Naval Treaty of 1922 had limited carrier tonnage for all signatories. The London Naval Treaty of 1930 had extended those limits. By 1941, the major naval powers had spent 2 decades building carriers within carefully negotiated constraints. They built them slowly, methodically, incorporating lessons learned from each new ship. Quality over quantity, experience over speed. That approach worked fine during peacetime. It failed catastrophically during war. The Japanese combined fleet had entered the Pacific War with the finest carrier force ever assembled. 6 fleet carriers participated in the Pearl Harbor attack: Akagi, Kaga, Soryu, Hiryu, Shokaku, and Zuikaku. For more fleet carriers, Hasho, Ryujo, Zuho, and Shoho operated in support roles. These were not hastily built vessels. They were the product of decades of naval aviation development, of hard-won experience, of careful refinement. Akagi had been laid down in 1920 as a battlecruiser, converted to a carrier after the Washington Treaty, and commissioned in 1927. She displaced 36,100 tons fully loaded. She carried 91 aircraft. Her flight deck measured 855 feet. She had been modified 3 times since commissioning, each modification improving her capabilities based on operational experience. Kaga had followed a similar path, laid down as a battleship in 1920, converted to a carrier, commissioned in 1928. She displaced 43,650 tons. She carried 90 aircraft. Her flight deck measured 812 feet. Together, Akagi and Kaga represented 17 years of construction and modification. Soryu commissioned in 1937. She was purpose-built as a carrier from the keel up, incorporating everything the Japanese had learned from Akagi and Kaga. She displaced 19,800 tons, carried 71 aircraft, achieved a top speed of 34 knots. She was fast, modern, efficient. Her sister ship Hiryu commissioned in 1939 with minor improvements. Shokaku and Zuikaku, commissioned in 1941 just months before Pearl Harbor, represented the pinnacle of Japanese carrier design. Each displaced 32,100 tons, carried 84 aircraft, could make 34 knots. They incorporated armored magazines, improved damage control systems, enhanced anti-aircraft batteries. They were, by every measure available in 1941, the finest aircraft carriers in the world. The Imperial Japanese Navy had spent 20 years building this force. They had invested billions of yen. They had trained thousands of aviators. They had developed doctrine, tactics, operational procedures. They had conducted exercises, war games, training missions. When they struck Pearl Harbor, They possessed not just carriers, but a complete carrier warfare system refined through 2 decades of focused effort. And they were confident it was enough. Japanese naval planning in 1941 assumed the war would be decided in 1 or 2 decisive battles. The combined fleet would destroy the American Pacific Fleet, establish control over the Western Pacific, secure the resource areas in Southeast Asia, then defend a perimeter while America negotiated peace. The strategy required maintaining carrier superiority for perhaps 18 months, maybe 2 years. After that, American industrial capacity would begin to matter, but by then Japan would have consolidated its gains behind defensive positions. The plan assumed America would build carriers the same way Japan built carriers. Slowly, one at a time, with years between keel laying and commissioning. The plan assumed that even American industrial capacity had limits when it came to complex warships. That assumption was wrong. On June 4, 1942, the assumption died at Midway. 4 Japanese fleet carriers, Akagi, Kaga, Soryu, and Hiryu, were sunk in a single day. 20 years of carrier development, 41 months of war preparation, half of Japan's frontline carrier strength, destroyed in one afternoon. The psychological impact on the Imperial Japanese Navy was devastating. These were not old ships written off as acceptable losses. These were the core of the fleet, the vessels that had struck Pearl Harbor, that had terrorized the Indian Ocean, that were supposed to anchor Japanese naval supremacy for years. Gone in 6 hours. Vice Admiral Chuchi Nagumo, who commanded the carrier force at Midway, returned to Japan in disgrace. He had lost half his strength in an engagement that was supposed to destroy the remaining American carrier force. Instead, the Americans had won decisively with 3 carriers, Enterprise, Hornet, and Yorktown, only losing Yorktown. The mathematics were ominous. Japan had entered the battle with 4 fleet carriers and 2 light carriers. They left with 2 light carriers. America had entered with 3 fleet carriers. They left with 2. But America also had Saratoga under repair and Wasp transferring from the Atlantic and word of new carriers under construction. The balance had shifted, and not in Japan's favor. The Imperial Japanese Navy immediately began planning replacement carriers. They would build new fleet carriers to replace the ones lost at Midway. They would convert merchant ships and naval auxiliaries into light carriers to increase numbers quickly. They would accelerate construction programs. They would rebuild the carrier force stronger than before. The problem was time. Building a fleet carrier took approximately 3 years from keel laying to commissioning. Japan laid down Taiho in July 1941. She would not commission until March 1944. 32 months of construction. Japan laid down Shinano in May 1940 as the 3rd Yamato-class battleship, then converted her to a carrier after Midway. She would require another 2 years of work before commissioning in November 1944. Light carriers could be built faster. Hyo and Junyo, converted from ocean liner hulls, commissioned in 1942 after 20 months of construction. Ryuho, converted from a submarine tender, commissioned in November 1942 after 14 months. Chitose and Chiyoda, converted from seaplane tenders, would commission in 1943. But these were conversions, compromises, ships that were adequate but not optimal. The Japanese plan called for building 23 new carriers by 1945, 15 fleet carriers, and 8 light carriers. The schedule assumed peacetime construction rates could be maintained during war. The schedule assumed shipyard capacity would remain available. The schedule assumed steel allocations would continue. The schedule assumed trained workers would not be conscripted. The schedule assumed American submarines would not interdict raw material shipments. Every one of those assumptions proved false. Captain Yasumi Doi commanded the shipyard at Kure Naval Arsenal, where Taiho was under construction. He was 54 years old, a naval architect who had overseen carrier construction since Akagi. He understood better than most the complexity of building these vessels. A fleet carrier required approximately 20,000 tons of steel plate in dozens of different thicknesses and specifications. The flight deck alone needed special tensile-strength steel that could handle the impact of landing aircraft. The hangar deck needed steel strong enough to support aircraft, but light enough not to compromise stability. The hull needed welding at tolerances measured in millimeters because any structural weakness would propagate under the stress of combat operations. The propulsion system required 4 separate steam turbine plants generating 160,000 shaft horsepower to achieve 33 knots. Each turbine had to be manufactured to specifications that kept efficiency within acceptable parameters across a range of operating conditions. The reduction gears that transferred power from the turbines to the propeller shafts were precision-engineered components that took months to machine. The boilers needed to generate superheated steam at pressures that required special steel alloys. One bad batch of steel, one improperly tempered component, one poorly executed weld, and the entire propulsion system could fail under operational stress. The aviation systems were even more complex. Elevators to move aircraft between the hangar and flight deck had to lift 6-ton aircraft reliably under combat conditions, including battle damage. The hydraulic systems that powered those elevators required miles of piping manufactured to specifications that prevented leaks at high pressure. The arresting gear system that stopped landing aircraft needed cables strong enough to absorb tremendous kinetic energy without snapping. The catapult system that launched aircraft needed to accelerate a 6-ton aircraft to flying speed in less than 200 feet without subjecting the pilot to G-forces that would cause unconsciousness. Fire suppression systems needed to flood magazines and fuel storage with inert gas or foam within seconds of damage. Ventilation systems needed to provide breathable air to compartments 5 decks below the waterline while removing smoke and fumes. Electrical systems needed to power everything from radar to radios to the galley where food was prepared for 2,000 crew members. Each system had to work reliably in conditions that included explosions, fires, flooding, and battle damage. Building a fleet carrier was not like building a factory or a bridge. It was building a mobile airbase that would operate under combat conditions thousands of miles from any repair facility. Every component had to be over-engineered because failure was not an option. Deutsch's workforce shrank month by month as skilled workers were conscripted for the army. Riveters who had spent years learning their craft were replaced by teenagers with 2 weeks of training. Welders who understood the specific techniques needed for naval steel were pulled to work on tank production. Electricians who knew carrier systems were sent to build fortifications on Pacific islands. The quality of work declined because the quality of workers declined. What had once taken a trained crew 6 hours now took an untrained crew 6 days, and the result was not as good. Material allocations became erratic. Steel that was supposed to arrive in July arrived in September, forcing construction delays. Copper wire that should have been delivered in August was redirected to submarine production. Ball bearings manufactured to carrier specifications were seized for aircraft engine production. Every shortage cascaded into other delays. You could not install electrical systems without wire. You could not complete turbine assembly without bearings. You could not launch the ship without completing the hull. The schedule that had called for Taiho to commission in January 1944 slipped to March. The schedule for subsequent carriers slipped further. By mid-1943, Deutsch understood that Japan was not going to build 23 carriers by 1945. They would be fortunate to commission 6. The resources were not available. The workers were not available. The industrial capacity was not available. And the Americans were sinking the merchant ships that brought raw materials from Southeast Asia. Without steel from Manchuria, without oil from the Dutch East Indies, without bauxite from Malaya, the shipyards could not function. The entire industrial base that supported carrier construction was being strangled by American submarines. Meanwhile, halfway across the Pacific, the United States was discovering that industrial capacity applied to carrier construction produced extraordinary results. The Essex-class fleet carrier program had been authorized in 1941 before Pearl Harbor. The design was conservative, based on Yorktown-class carriers with improvements. Essex would displace 27,500-ton standard 36,000 tons fully loaded. She would carry 90 aircraft, achieve 33 knots, incorporate lessons learned from Coral Sea and Midway. Congress had initially authorized 11 ships. After Pearl Harbor, they authorized 24, then 32. Eventually, the program would include 32 Essex-class carriers and 9 Independence-class light carriers converted from cruiser hulls. 41 carriers total. But authorization was not construction. The question was whether American shipyards could actually build them. The first Essex-class carrier, USS Essex herself, was laid down at Newport News Shipbuilding on April 28, 1941. She commissioned on December 31, 1942. 20 months from keel to commissioning. That was faster than any fleet carrier had ever been built. The second carrier, Yorktown, named for the carrier sunk at Midway, was laid down December 1, 1941. She commissioned April 15, 1943. 16 months. Intrepid, laid down December 1, 1941, commissioned August 16, 1943. 20 months. Hornet, laid down August 3, 1942, commissioned November 29, 1943. 15 months. The construction times kept dropping. Shipyards were learning. Workers were gaining experience. Production techniques were being refined. What had taken 20 months for the first ship took 15 months for later ships. And multiple ships were being built simultaneously. Newport News was building carriers while Philadelphia Naval Shipyard built carriers, while New York Naval Shipyard built carriers, while Norfolk Naval Shipyard built carriers. For separate yards, all building Essex-class carriers, all learning from each other, all improving their methods. The Independence-class light carriers were even faster. These were cruiser hulls converted to carry aircraft. USS Independence herself was laid down as a Cleveland-class light cruiser in May 1941. In February 1942, after Pearl Harbor, she was redesignated as a carrier. Work continued without stopping, the hull modified during construction rather than built and then converted. She commissioned in January 1943. 20 months total, but only 11 months as a carrier. Princeton commissioned in February 1943. Belowood in March. Cowpens in May. Monterey in June. Langley in August. 9 light carriers commissioned between January and August 1943. 9 carriers in 8 months. By the end of 1943, the United States Navy had commissioned 6 Essex-class fleet carriers and 8 Independence-class light carriers. 14 new carriers in 1 year. Japan had commissioned 2 carriers in 1943, both converted from other hull types. The disparity was stark and growing. The question was not whether America could build carriers faster than Japan. America had already proven that. The question was whether America could build carriers faster than Japan could sink them. At Imperial General Headquarters in Tokyo, naval staff officers looked at intelligence reports about American carrier construction with growing alarm. The numbers seemed impossible. How could any nation build 14 carriers in 1 year? The reports had to be exaggerated, propaganda, deception. But reconnaissance photographs from submarines showed multiple carriers under construction at American yards. Radio intercepts confirmed new carriers joining the fleet. Capture documents mentioned ship names that Japanese intelligence had never heard of. The Americans were not exaggerating. They were building carriers at a rate that Japanese planners had not thought possible. The strategic implications were catastrophic. Japan's plan had always assumed rough parity in carrier strength. If Japan lost carriers, America would also lose carriers. Attrition would favor Japan because Japanese pilots were better trained, Japanese torpedoes were more effective, Japanese night fighting capabilities were superior. But if America could replace losses faster than Japan, if America could build 2 carriers for every 1 Japan built, then attrition favored America. Every battle would weaken Japan while strengthening America. The mathematics were inescapable. Admiral Osami Nagano, Chief of the Navy General Staff, convened a planning conference in February 1943 to address the carrier imbalance. Present were representatives from the combined fleet, the Naval General Staff, the Ministry of Munitions, and the Shipbuilding Bureau. The meeting lasted 3 days. The conclusion was unanimous and devastating. Japan could not match American carrier production. The industrial capacity did not exist. The raw materials could not be guaranteed. The skilled labor force was shrinking. Even if every obstacle were overcome, Japanese shipyards could realistically commission perhaps 8 new fleet carriers by the end of 1945. Intelligence estimates suggested America would commission over 30 in the same period. Captain Toshikazu Aomi, who served on the Naval General Staff, later wrote that the February 1943 conference marked the moment when senior officers understood the war was unwinnable. Not because Japanese forces lacked courage or skill, but because the material imbalance could not be overcome. You could not defeat an enemy who built carriers 4 times faster than you could. You could train better pilots, develop better tactics, fight more aggressively, and still lose because the enemy could absorb losses that would cripple you. The fundamental problem was that Japan and America had industrialized differently. Japan had built an industrial economy focused on light manufacturing, textiles, small-scale production. Heavy industry existed, shipyards, steel mills, aircraft factories, but these were concentrated in specific locations and vulnerable to disruption. The Japanese economy in 1941 was approximately 10% the size of the American economy. That disparity mattered less when building small quantities of high-quality weapons. It mattered enormously when building large quantities of anything. American industrial capacity in 1941 was the product of a century of continuous expansion. The United States had more steel mills than Japan had blast furnaces. American shipyards stretched from Maine to California, from the Great Lakes to the Gulf Coast. When war began, those yards were building merchant ships, tankers, freighters, basic vessels that required relatively simple techniques. Converting that capacity to warship construction took time, but not fundamental reorganization. Workers who could weld a merchant ship hull could weld a carrier hull. The techniques were similar. The scale was larger. The specifications were tighter. But the basic skills transferred. The United States Maritime Commission, established in 1936, had spent 5 years preparing American shipyards for war production. They had standardized designs, pre-positioned materials, trained workers. When war came, the groundwork was already laid. The Commission had authorized construction of 200 cargo ships before Pearl Harbor. After Pearl Harbor, they authorized thousands. The Liberty Ship Program alone would produce 2,710 cargo ships between 1941 and 1945. Henry Kaiser's shipyards, using prefabrication and assembly line techniques borrowed from automobile manufacturing, reduced construction time for a Liberty ship from 230 days to 42 days. The SS Robert E. Peary was built in 4 days, 15 hours, and 29 minutes as a demonstration of what was possible. Those same techniques applied to carrier construction. Prefabricate major assemblies. Build sections in different areas of a yard simultaneously. Bring them together for final assembly. Use welding instead of riveting where possible because welding was faster and required less skill. Standardize components so that workers could specialize. An electrician who wired the same compartment on 6 different carriers became very good at wiring that compartment very quickly. A welder who welded the same whole section repeatedly learned the most efficient techniques. The learning curve was steep and consistent. Newport News Shipbuilding employed 8,000 workers in 1939. By 1943, they employed 31,000. Many were women who had never worked in heavy industry before. Rosie the Riveter was not a fictional character. She was thousands of real women who learned to rivet, weld, wire, and assemble carriers on schedules that shipyard foremen in 1939 would have called impossible. The yard operated 3 shifts, 24 hours per day, 7 days per week. On any given day, multiple carriers were under construction simultaneously, each at a different stage of completion. Workers moved from ship to ship as needed. Supervisors coordinated schedules to ensure critical path items received priority. Management tracked progress with charts that measured work completed per man-hour, per day, per week. The Philadelphia Navy Yard employed 9,000 workers in 1939. By 1943, they employed 40,000. They built not just carriers but battleships, cruisers, destroyers, submarines. The yard occupied over 1,000 acres along the Delaware River. It had 7 building ways capable of handling large warships, multiple dry docks for repairs, foundries, machine shops, electrical shops, everything needed for complete ship construction. When Essex-class carriers were authorized, Philadelphia geared up to build them, using the same systematic approach they applied to every vessel. Break the construction process into discrete tasks. Assign each task to specialized crews. Measure progress daily. Identify bottlenecks immediately. Solve problems before they cascaded into delays. One critical bottleneck was propulsion machinery. Essex-class carriers required 4 Westinghouse steam turbines generating 150,000 shaft horsepower. Each turbine was a precision-engineered piece of equipment that weighed over 60 tons and contained thousands of parts machined to tolerances measured in thousandths of an inch. In peacetime, Westinghouse built turbines one at a time, carefully testing each component. In wartime, they built turbines in batches, manufacturing multiple identical units simultaneously. Quality control remained rigorous, but production methods changed. Instead of one team building one turbine from start to finish, multiple teams built multiple turbines with each team specializing in specific subassemblies. The rotor team built rotors. The casing team built casings. The valve team built valves. Final assembly brought components together. Testing verified performance. The result was turbines built in half the time without compromising reliability. The same approach applied to every major component. Reduction gears came from General Electric's plant in Lynn, Massachusetts. They manufactured gears for multiple carriers simultaneously, using specialized machinery that automated what had once been manual operations. Boilers came from Babcock and Wilcox in Barberton, Ohio. They built carrier boilers on an assembly line, each boiler moving through sequential workstations where different tasks were performed. By 1943, they were completing one carrier boiler set every 2 weeks. That pace would have been inconceivable in 1939. Aircraft elevators, arresting gear, catapults, fire suppression systems, radar sets, radio equipment. Everything came from specialized suppliers who had ramped up production using the same techniques. Break complex assemblies into subcomponents. Manufacture subcomponents in batches. Assemble them systematically. Test rigorously. Ship on schedule. The United States had discovered that you could mass-produce almost anything if you applied sufficient organizational discipline and industrial capacity. Even aircraft carriers. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By mid-1943, American carriers were joining the fleet faster than they could be properly worked up. USS Lexington, the second ship to bear that name, commissioned in February 1943. She conducted shakedown training in the Caribbean, worked up her air group, and deployed to the Pacific in August. 6 months from commissioning to combat deployment. USS Bunker Hill commissioned in May 1943, deployed to the Pacific in August. 3 months from commissioning to combat. The Navy was learning that shakedown periods could be compressed if air groups trained separately and joined the ship just before deployment. Carrier crews could learn their jobs while the ship transited to the combat zone. Japanese carriers, by contrast, required extensive post-commissioning training. Taiho commissioned in March 1944. She spent 3 months working up before being considered combat ready. Her air group needed time to qualify on a new carrier. Her crew needed time to master damage control procedures. Her systems needed testing under operational conditions. You could not simply commission a carrier and send her immediately into battle. Or rather, Japan could not. America was proving that with proper training structures, you could. The American system trained replacement pilots in the United States, then sent them to operational squadrons in the Pacific. The squadrons trained on escort carriers that had been designated as training carriers. When a fleet carrier needed a new air group, that air group arrived already trained, already qualified, ready to operate. The carrier herself trained separately, working her crew through damage control exercises, flight operations training, gunnery practice. When carrier and air group came together, both were ready. The efficiency was remarkable. What Japan did sequentially, America did in parallel, cutting months from the process. By October 1943, the United States Pacific Fleet had 8 Essex-class fleet carriers operational. Essex, Yorktown, Intrepid, Hornet, Lexington, Bunker Hill, Wasp, and Hancock. 8 Independence-class light carriers were also operational. Independence, Princeton, Below, Wood, Cowpens, Monterey, Langley, Cabot, and Bataan. 16 new carriers in less than 2 years. Japan had commissioned Taiho in July 1942, Junyo in August 1942, and Ryuho in November 1942. 3 carriers in a year and a half, all conversions. The ratio was devastating. 5 American carriers for every Japanese carrier. And the American production rate was accelerating while the Japanese rate was declining. Admiral Minaichi Koga, who had replaced Yamamoto as commander of the combined fleet after Yamamoto's death in April 1943, understood the mathematics perfectly. He had 9 operational fleet carriers in October 1943. Shokaku, Zuikaku, Taiho, Junyo, Ryuho, Zuho, Chitose, Chiyoda, and Yunyo. The Americans had 16 in the Pacific and more in the Atlantic. By the time Japan commissioned Taiho in March 1944, the Americans would have 24. By the time Japan commissioned Shinano in November 1944, if she commissioned at all given the material shortages, the Americans would have 30 or more. Koga's strategic options were limited. He could not fight a war of attrition because America would win. He could not avoid battle because Japan needed to stop the American advance. His only option was to seek a decisive battle where superior Japanese training and tactics could overcome American numerical superiority. He needed to find a place where American carriers would be forced to fight on terms that favored Japan. He needed terrain, weather, or circumstances that would neutralize American advantages. He needed luck. The plan that emerged from this thinking was Operation A-Go. A defense of the Marianas with a combined fleet would engage the American carrier force in waters close to Japanese-held islands. Land-based air power from those islands would supplement carrier air power. The Japanese would achieve local superiority through concentration. They would destroy enough American carriers to restore balance. They would make the Americans reconsider their advance. It was the only plan that offered any chance of changing the strategic situation. The problem was that the plan required more carriers than Japan had and better pilots than Japan could provide. Koga had 9 carriers in October 1943. He would need every one of them for Operation A-Go. He could not afford to lose any in preliminary actions. He could not afford to waste pilots. He could not afford to disperse his strength. Every carrier had to be preserved. Every pilot had to be husbanded. The fleet would stay concentrated, avoid combat except under favorable circumstances, and wait for the decisive battle. That strategy meant surrendering initiative to the Americans. It meant allowing American forces to advance unopposed. It meant giving up islands, bases, strong points. But Koga had no alternative. He did not have enough carriers to fight everywhere. He had to choose where to fight and conserve strength until that moment arrived. The Americans, by contrast, did not need to conserve anything. They had carriers in abundance. If one was damaged, 2 more were available. If an air group suffered casualties, replacement pilots arrived within weeks. If a ship needed major repairs, she returned to Pearl Harbor while others continued operations. The American carrier force in the Pacific operated continuously from August 1943 onward. Strikes against Marcus Island. Strikes against Wake Island. Strikes against Rabaul. Strikes against Truk. Always moving, always attacking, always keeping pressure on Japanese defenses. Japanese forces could do nothing except endure the attacks and wait for their chance. Lieutenant Commander Takahide Ajoi commanded the carrier Zuikaku's fighter squadron in late 1943. He was 29 years old, a veteran of Pearl Harbor, Coral Sea, and every major carrier engagement since. He had shot down 7 American aircraft. He was one of the most experienced fighter pilots remaining in the combined fleet. In December 1943, his squadron included 21 pilots. 14 of them had less than 6 months of carrier experience. 7 had less than 3 months. The veteran pilots who had struck Pearl Harbor were dead, transferred to training duties, or too exhausted to continue flying. AIY was training replacements while trying to maintain combat readiness while preserving his force for the decisive battle that headquarters promised was coming. The replacements were not incompetent. They had completed flight training. They could take off and land on a carrier. They could fly formation. But they had not accumulated the hundreds of hours of flight time that turned adequate pilots into excellent pilots. They had not fought American fighters. They had not learned the instincts that kept you alive in combat. Japanese pilot training programs in 1943 were producing pilots at twice the peacetime rate, but those pilots had half the training hours. Peacetime training had required 700 hours before carrier qualification. Wartime training provided 350 hours. You could teach someone to fly in 350 hours. You could not teach them to survive against American pilots who had 500 hours of training plus combat experience. The American pilot training system had scaled up without significantly reducing quality. In 1941, the Navy trained 1,000 pilots per year. By 1943, they were training 10,000 pilots per year. The training was standardized, systematic, thorough. Primary training in single-engine aircraft. Basic training in combat-type aircraft. Advanced training in fighters, dive bombers, or torpedo bombers, depending on assignment. Operational training with fleet squadrons. By the time an American pilot reached a carrier in the Pacific, he had logged 500 to 600 flight hours. He had fired his guns at aerial targets. He had practiced dive bombing and torpedo runs. He had simulated combat against instructors flying enemy tactics. He was not yet an expert, but he was competent, and competence combined with numerical superiority was enough. AIY understood what was happening. He was training pilots who would die in their first or second combat mission because they did not have the experience to survive against odds that were increasingly unfavorable. He was sending boys to fight men, and there was nothing he could do about it except train them as well as possible in the time available and hope that some of them would survive long enough to become veterans. But the mathematics were merciless. If Japan lost pilots faster than it could train them, and if America produced pilots faster than Japan could kill them, then eventually Japanese carriers would have no one to fly their aircraft. The carriers would still exist. They would still be operational, but they would be useless because you could not fight a carrier war without trained carrier pilots. That realization was spreading through the combined fleet by early 1944. Maintenance officers looked at replacement parts that were not arriving and understood that carriers would be increasingly difficult to keep operational. Logistics officers looked at fuel allocations that kept declining and understood that training exercises would have to be curtailed. Intelligence officers looked at reports of American carriers flooding into the Pacific and understood that numerical parity would never be restored. The decisive battle Koga was planning would have to be fought with inferior numbers, inadequate pilot training, reduced fuel reserves, and lengthening supply lines. It would have to be fought because there was no alternative. But everyone involved understood the odds were not favorable. At Kure Naval Arsenal, Captain Doi watched Taiho near completion in January 1944. She was magnificent. 37,700 tons displacement. Armored flight deck, the first Japanese carrier so equipped. She could carry 75 aircraft. She could make 33 knots. She incorporated every lesson learned from 3 years of carrier warfare. She was, in Doi's professional opinion, the finest carrier Japan had ever built. She was also almost certainly the last fleet carrier Japan would complete during the war. Shinano might commission in November if steel allocations held, and if workers remained available, and if American submarines did not interdict raw materials. After Shinano, there were no more fleet carriers under construction. The program had been canceled. The resources were needed elsewhere. Doi had spent his career building carriers. He understood their strategic importance. He understood that without carriers, Japan could not contest control of the Pacific. He also understood that building one carrier per year, while America built 15 carriers per year, was not a strategy for victory. It was a strategy for prolonged defeat. Taiho would enter service. She would fight. She would probably be sunk, because every carrier eventually got sunk if you fought long enough against superior numbers. And after Taiho was gone, there would be no replacement. The combined fleet was consuming its carrier strength in a war it could not win, because American industry had made winning impossible. The doctrine that had guided Japanese naval strategy since the Washington Naval Treaty assumed that quality could offset quantity. Build fewer ships, but make them excellent. Train fewer pilots, but make them superb. Fight fewer battles, but win decisively. That doctrine worked when quantity differentials were modest. It failed when one side could build 5 carriers for every carrier the other side built. No amount of quality could overcome that disparity. You could build the best carrier in the world. You could train the best pilots in the world. You could fight brilliantly. And you would still lose because the enemy could afford to trade 3 carriers for one of yours and still have more carriers remaining than you had at the start. Taiho commissioned on March 7, 1944. Her crew numbered 1,738 officers and men. Her air group consisted of 18 fighters, 27 dive bombers, and 18 torpedo bombers. She was assigned to the 1st Mobile Fleet under Vice Admiral Jisaburo Ozawa. Ozawa was 58 years old, a torpedo warfare specialist who had assumed command of the combined fleet's carrier forces in November 1943 after Koga reorganized the fleet structure. He looked at Taiho and saw what everyone else saw, a magnificent ship that would not be enough. Ozawa's command in March 1944 included 9 carriers. 3 fleet carriers, Taiho, Shokaku, and Zuikaku. 6 light carriers, Hayo, Junyo, Ryoho, Zuho, Chitose, and Chiyoda. Those 9 carriers represented Japan's entire operational carrier strength. There were no reserves. There were no replacements under construction that would commission within 12 months. What Ozawa had was what Japan had. Intelligence reports indicated the American Fifth Fleet had assembled 15 carriers for operations in the Central Pacific. Task Force 58 alone, the Fast Carrier Task Force, included 12 carriers. Essex, Yorktown, Intrepid, Hornet, Lexington, Bunker Hill, Wasp, Enterprise, Below, Wood, Cowpens, Monterey, and Cabot. The Americans had deployed more carriers than Japan possessed in total, and American carriers operating from forward bases near the Marianas would have land-based air support. Japanese carriers operating from bases in the Philippines would not. The disparity went beyond numbers. American carriers in mid-1944 carried larger air groups than their Japanese counterparts. An Essex-class carrier embarked 90 aircraft, 36 fighters, 36 dive bombers, 18 torpedo bombers. A light carrier embarked 33 aircraft, 24 fighters, 9 torpedo bombers. American air groups totaled approximately 1,000 aircraft across 12 carriers. Japanese air groups totaled approximately 450 aircraft across 9 carriers. The Americans had more than twice as many carrier-based aircraft, and those aircraft were often superior to their Japanese equivalents. The F-6F Hellcat fighter that equipped American carrier squadrons in 1944 was faster, more durable, and more heavily armed than the Zero fighters that equipped Japanese squadrons. The Hellcat could absorb battle damage that would destroy a Zero. It carried 6 50-caliber machine guns that could tear apart enemy aircraft at ranges where the Zero's lighter weapons were ineffective. American pilots called it a flying tank. Japanese pilots called it a problem they could not solve. You could not outrun it because it was faster. You could not outlast it because it had longer range. You could not outturn it at high speeds because American design philosophy emphasized performance at combat speeds rather than theoretical maneuverability. The only advantage the Zero retained was low-speed turning radius, which mattered very little when Hellcats attacked from altitude with speed advantages that let them dictate engagement terms. American dive bombers and torpedo bombers had similar advantages. The SB-2C Helldiver could carry a 2,000-pound bomb load, twice what Japanese dive bombers carried. The TBF Avenger torpedo bomber was larger, faster, and more survivable than Japanese torpedo bombers. It carried defensive armament that made attacking it dangerous. American aircrew survival rates reflected these advantages. When American aircraft was shot down over water, rescue submarines and seaplanes often recovered the crew. When a Japanese aircraft was shot down, the crew usually died because Japan lacked comparable rescue capabilities. Over time, this meant American squadrons retained experienced aircrew, while Japanese squadrons lost their veterans and could not replace them with equivalently trained pilots. Ozawa understood all of this. He understood the mathematics, the material disparities, the pilot quality differences. He also understood that he had to fight because there was no alternative. American forces were advancing through the Central Pacific, capturing islands, building airfields, moving closer to the Philippines. If the Philippines fell, Japan's access to oil and raw materials from Southeast Asia would be severed. Without oil, the fleet could not operate. Without raw materials, industry could not function. The war would be lost not through defeat in battle, but through strangulation of resources. Operation Ago was Japan's last chance to stop the American advance. It had to work. There was no plan B. The American advance Ozawa was trying to stop had reached the Mariana Islands by June 1944. The Fifth Fleet under Admiral Raymond Spruance was preparing to invade Saipan. The invasion would begin June 15th. Japanese forces would resist. The combined fleet would sortie to destroy the American invasion force. The decisive battle that Japan had been planning for 2 years was about to happen, whether Japan was ready or not. On June 13, 1944, Ozawa's first mobile fleet departed Taiho in the southern Philippines. 9 carriers, 5 battleships, 13 cruisers, 28 destroyers. Every major surface combatant Japan could spare. They were sailing to meet an American force that included 15 carriers, 7 battleships, 21 cruisers, and 69 destroyers. The Americans had numerical superiority in every category, but Ozawa had a plan. The plan relied on geography and aircraft range. Japanese carrier aircraft had longer range than American carrier aircraft. A Zero could fly 375 miles to a target. A Hellcat could fly approximately 275 miles. That 100-mile difference meant Japanese carriers could launch strikes from distances where American carriers could not effectively retaliate. Ozawa would position his carriers 300 miles from the American fleet, launch strikes, recover those strikes, and repeat. American carriers would be unable to strike back because they could not reach his fleet. Additionally, Japanese aircraft attacking American carriers could continue westward after their attack and land at airfields on Guam or Rota in the Marianas, refuel, rearm, and launch again. The Americans called it a shuttle bombing strategy. Ozawa called it his only chance to overcome American numerical superiority. The plan assumed Japanese land-based air forces in the Marianas would still be operational when the battle began. Those forces, approximately 500 aircraft, would supplement carrier air power and divide American attention. The plan assumed Japanese reconnaissance would locate American carriers before American reconnaissance located Japanese carriers. The plan assumed Japanese air groups would maintain formation discipline during strikes and would not suffer catastrophic losses to American fighters. Every one of those assumptions would prove false. American submarines detected Ozawa's fleet as it departed Taiho. Radio intercepts confirmed a major fleet movement toward the Marianas. By June 14th, Spruance knew the combined fleet was coming. He positioned his carriers to intercept. Task Force 58 under Vice Admiral Mark Mitcher deployed west of Saipan, between the invasion beaches and the expected Japanese approach route. Mitcher had 7 Essex-class fleet carriers and 8 light carriers, the most powerful naval aviation force ever assembled. He had 961 aircraft immediately available with more in reserve. His orders were simple: find the Japanese carriers and destroy them. The Fifth Fleet would not be surprised. The Fifth Fleet would not be caught unprepared. The Fifth Fleet had been waiting for this battle since Midway. On June 19th, 1944, the Battle of the Philippine Sea began at dawn. Japanese reconnaissance aircraft located American carriers at approximately 0730 hours. Ozawa launched his first strike at 0830 hours. 69 aircraft, 45 fighters, 8 torpedo bombers, 16 dive bombers. They flew eastward toward the American fleet. American radar detected them at 0955 hours when they were still 150 miles away. Mitchell launched interceptors. F-6F Hellcats climbed to altitude and positioned themselves between the incoming Japanese strike and the American carriers. The Hellcats had altitude advantage, numbers advantage, and tactical position advantage. What followed was less a battle than a slaughter. The Japanese formation leader was Lieutenant Commander Akira Terui. He was leading his first combat mission as formation commander. He had been promoted 3 weeks earlier after his predecessor was killed over truck. Terui was a competent pilot, but he was leading pilots who had minimal combat experience against American pilots who had been fighting for months. The formation flew into the American fighter screen at 01020 hours. Hellcats dove through the Japanese formation, breaking it apart. Zeros tried to engage. American pilots used tactics refined through years of combat. Never dogfight with Zeros. Use speed and altitude to attack. Dive through the formation, shoot, escape. Let the next division make the next pass. Keep attacking until the Japanese formation disintegrates. Terui's strike never reached the American carriers. 42 of 69 aircraft were shot down. The survivors dropped their ordnance harmlessly into the ocean and fled. Only 27 aircraft returned to their carriers. Terui was not among them. Ozawa launched a second strike at 0856 hours. 128 aircraft. They flew toward the American fleet. American radar detected them. More Hellcats launched. The same pattern repeated. Japanese formations disintegrated under sustained fighter attack. Bombs fell into empty ocean. Torpedoes ran uselessly. Aircraft crashed, burning into the sea. 47 Japanese aircraft were lost. 81 returned. Most had not reached their targets. The few that did scored no hits. 0 damage to American carriers. 91 Japanese aircraft lost. The morning was not yet over. Ensign Sakae Yamamoto flew in the third strike launched at 1000 hours. 47 aircraft from Taiho's air group. Yamamoto flew a Zero fighter. He was supposed to escort dive bombers to the American fleet. He was supposed to protect them from American fighters. He had been flying for 11 months. He had never been in combat before today. At 1022 hours, while the strike was forming up over the fleet, USS Albacore, an American submarine, fired 6 torpedoes at Taiho. 1 torpedo hit Taiho on her starboard side forward. The explosion ruptured aviation fuel tanks and damaged the forward elevator. Yamamoto watched from above as smoke began pouring from his carrier. His strike continued eastward. There was nothing he could do. Orders were to attack American carriers, not return to defend his own ship. The third strike flew into the same destruction that had claimed the first 2 strikes. American fighters intercepted. Yamamoto saw Hellcats diving through his formation. He saw dive bombers exploding as 50 caliber rounds tore through their fuel tanks. He saw Zeros attempting to engage and being shot apart. He fired his guns at a Hellcat that flashed past too quickly to track. He lost formation. He became separated. He circled alone at 12,000 feet, watching his strike force disintegrate below. When the attack ended, he turned back toward Taiho. 31 of 47 aircraft had been lost. Yamamoto survived. When he returned to his carrier 3 hours later, Taiho was sinking. The single torpedo hit at 1022 hours had not been immediately catastrophic. Taiho's armored flight deck had protected her from worse damage. Her damage control teams were containing flooding. But aviation fuel vapor from ruptured tanks had begun accumulating throughout the ship. An inexperienced damage control officer ordered ventilation systems activated to disperse the fumes. The ventilation systems spread fuel vapor to every compartment instead of venting it overboard. At 2:32 hours in the afternoon, 7 hours after the torpedo hit, something ignited the vapor. The explosion was catastrophic. Taiho's armored flight deck, the feature that was supposed to make her survivable, became a lid-trapping explosive force inside the hull. The ship's structure failed. Secondary explosions followed. Magazines detonated. The flight deck buckled. At 3:28 hours, Vice Admiral Ozawa transferred his flag to the cruiser Higuro. At 4:28 hours, Taiho capsized and sank. 1,650 men went into the water. 500 survived. Yamamoto was not among them. He had landed aboard Zuikaku 2 hours earlier when it became clear Taiho could not recover aircraft. He survived the battle. He died 2 months later in the Philippines when his Zero was shot down during an attack on American forces landing at Leyte. Taiho's loss was devastating but not unprecedented. Carriers sunk were tragedies, but also expected casualties of naval warfare. What was unprecedented was the destruction of Japanese naval aviation that occurred during the Battle of the Philippine Sea. Ozawa launched 4 strikes, totaling 373 aircraft. Only 135 returned. 238 aircraft lost in one day. Most of the pilots were killed. The few who survived and made it to Guam or Rota found those airfields under American attack and unusable for recovery. They crashed attempting to land on damaged runways. They ran out of fuel searching for safe landing sites. They ditched in the ocean and drowned. The carrier air groups that had taken years to train were destroyed in hours. American aircrew called it the Great Marianas Turkey Shoot. Japanese commanders called it the end of Japanese naval aviation. The 4th Japanese strike, launched in the afternoon, never found the American fleet. It became lost, ran low on fuel, and attempted to land on Guam. American fighters intercepted the landing aircraft and shot them down over their own airfield. 73 aircraft launched. 9 returned. The massacre was so complete that American pilots began to feel something approaching pity for the Japanese aviators they were killing. These were not the veteran pilots of Pearl Harbor and Midway. These were undertrained replacements being sent to die by commanders who had no other options. On June 20th, American carriers located the surviving Japanese fleet and launched strikes. The attacks sank 1 carrier, Taiho, damaged 2 others, and sank 2 oilers. Ozawa retreated westward with 4 fleet carriers and 4 light carriers. All had suffered aircraft losses. Many had battle damage. None had intact air groups. The combined fleet still possessed 8 carriers after the Battle of the Philippine Sea. Those carriers were effectively useless because they had almost no trained pilots remaining to fly from them. Vice Admiral Takejiro Onishi, who would later organize the Kamikaze Special Attack Corps, wrote in July 1944 that Japan had lost the air war irreversibly. The few remaining veteran pilots could not train enough replacements to matter. American carrier forces were growing stronger while Japanese forces were growing weaker. Within 6 months, possibly less, Japan would be unable to contest American air superiority anywhere in the Pacific. His assessment was prescient. By October 1944, during the Battle of Leyte Gulf, Japanese carriers functioned primarily as decoys. They had aircraft aboard, but no pilots capable of flying effective combat missions. The carriers sortied northward to draw American attention, while Japanese surface forces attempted to attack the invasion fleet from the west. The strategy worked in the sense that American carriers pursued the Japanese carriers. It failed in the sense that Japanese surface forces were defeated anyway, and the carriers that had been used as bait were sunk having accomplished nothing. 4 carriers lost: Zuikaku, Zuho, Chitose, and Chiyoda. Japan was left with 4 operational carriers and no trained air groups to operate from them. The final carrier, Shinano, commissioned on November 19th, 1944. She was the largest carrier ever built to that point, 68,000 tons displacement, converted from a Yamato-class battleship hull. She could carry 47 aircraft. She had an armored flight deck 18 inches thick. She incorporated every damage control lesson Japan had learned. She was supposed to be unsinkable. She sortied from Yokosuka Naval Arsenal on November 28th for transit to Kure, where she would complete fitting out and work up her air group. She never arrived. At 0317 hours on November 29th, USS Archerfish, an American submarine, fired 6 torpedoes. 4 hit Shinano's starboard side. Flooding could not be controlled. At 10:57 hours on November 29th, Shinano sank. She had been in commission for 10 days. She had never launched or recovered a single aircraft. She was the largest warship ever sunk by a submarine. By December 1944, Japan had 2 operational carriers remaining. Hasho, the old training carrier that had been in service since the 1920s, and Katsuragi, a converted carrier that commissioned in October. Neither had air groups. Neither sortied again during the war. They survived until surrender by remaining in port. The Imperial Japanese Navy that had begun the war with 10 carriers and dreams of maintaining carrier superiority had been reduced to 2 obsolete carriers without aircraft, sitting at anchor while American carrier task forces struck Japan itself with impunity. The American carrier fleet by December 1944 included 27 Essex-class fleet carriers and 9 Independence-class light carriers. 36 carriers. The Navy had 15 more Essex-class carriers under construction. They would commission between January and August 1945. By the time Japan surrendered in August 1945, the United States Navy had over 50 fleet and light carriers operational or completing fitting out. Japan had 0 carriers capable of conducting flight operations. The mathematics that Imperial General Headquarters had tried to ignore in February 1943 had come to their inevitable conclusion. You could not defeat an industrial power that could build carriers faster than you could sink them. You could not win a war of attrition when the enemy replaced losses at 5 times the rate you could. You could fight brilliantly, train superbly, sacrifice willingly, and still lose because industrial capacity determined the limits of what courage and skill could accomplish. The question of why Japan lost the carrier war was asked repeatedly after the war ended. American analysts studied Japanese shipyards, industrial capacity, raw material access. They concluded that Japan never had the industrial base to compete with American carrier production. Japanese steel production in 1944 was approximately 8 million tons. American steel production in 1944 was 89 million tons. Japan produced less than 1/10 the steel America produced. Every carrier, every battleship, every cruiser, every destroyer required steel. Every aircraft required aluminum. Every ship required copper for electrical systems. Every vessel required skilled workers to build them. Japan had limited quantities of all these resources. America had them in abundance. But the disparity went deeper than raw resources. It was a difference in industrial philosophy. Japanese industry in 1941 was organized around small-scale, high-quality production. Craftsmen built components one at a time. Quality control was meticulous. The result was excellent but slow. American industry was organized around mass production. Design components that could be manufactured quickly, standardize parts so they were interchangeable, use assembly line techniques to maximize output, except that some units would have minor defects that could be corrected during fitting out. The result was adequate quality at high speed. In peacetime, the Japanese approach produced better individual ships. In wartime, the American approach produced more total ships and more ships won. The United States also benefited from geography. American shipyards on the East Coast, West Coast, and Gulf Coast were thousands of miles from any Japanese threat. They operated without fear of air raids or submarine attacks. Workers built carriers knowing they would not be bombed while welding hull plates. Japanese shipyards at Kure, Yokosuka, Sasebo, and Nagasaki operated under increasing threat as the war continued. By 1945, American carrier aircraft were striking those yards directly. Workers built carriers while air raid sirens wailed. Productivity declined not because workers were less skilled, but because working under threat of imminent death affected concentration and morale. American submarine operations strangled Japanese carrier construction more effectively than any bombing campaign could have. Submarines sank the merchant ships carrying steel from Manchuria, oil from the Dutch East Indies, bauxite from Malaya. Without raw materials, shipyards could not function. Construction schedules that called for 12 months stretched to 18 months, then 24 months, then were canceled entirely because the steel never arrived. The submarines also sank completed carriers. Shinano sunk by Archerfish. Taiho sunk by Albacore. Shokaku sunk by Kavala during the Battle of the Philippine Sea. American submarines operating in waters where Japanese anti-submarine warfare capabilities were inadequate accomplished what battleships and bombers could not. They removed Japanese carriers from the war before those carriers could affect outcomes. The final factor was pilot training. Japan began the war with approximately 3,500 trained carrier pilots. These were the men who had attacked Pearl Harbor, who had terrorized the Indian Ocean, who had fought at Coral Sea and Midway. They were superb. By mid-1943, most of them were dead. The replacements were not superb. They were adequate at best. By mid-1944, even the adequate pilots were gone, replaced by barely trained teenagers flying obsolete aircraft against experienced American pilots flying superior aircraft. No amount of industrial capacity could have overcome that disparity, but industrial capacity made it worse. American training programs produced 10 pilots for every pilot Japan produced. American carriers embarked 90 aircraft, while Japanese carriers embarked 60. American squadrons rotated home after combat tours, rested, trained replacement pilots, and returned. Japanese squadrons fought until destroyed, trained no replacements, and disappeared. The mathematics were merciless. Captain Toshikazu Ami, who had attended the February 1943 conference where naval staff officers first understood the war was unwinnable, survived the war, and wrote extensively about Japanese naval strategy. In his post-war writings, he noted that Japan's carrier construction program was ambitious on paper, but completely detached from reality. The plan called for building carriers at rates Japanese industry could not sustain. The plan assumed access to raw materials that American submarines were interdicting. The plan assumed trained workers who were being conscripted for the Army. The plan assumed time that Japan did not have. He wrote that Japanese planners had made a fundamental error. They planned for the war they wanted to fight rather than the war they could fight. They wanted a short war decided by decisive battles. They planned carrier construction accordingly. They got a long war of attrition. Their carrier construction program collapsed because it was designed for a different war. American planners, by contrast, planned for industrial war from the beginning. The Essex-class program, authorized in 1941, assumed a multi-year conflict. It assumed continuous construction. It assumed losses would need to be replaced. It assumed that whoever built more carriers faster would have a decisive advantage. They were correct. The Two-Ocean Navy Act of 1940, passed more than a year before Pearl Harbor, had authorized construction of 200 warships, including 11 Essex-class carriers. The planning began before the war. The authorization came before the war. The construction started before the war. When war came, America was already building the fleet that would win it. The lesson was clear, but difficult for many to accept. Courage, training, and tactical skill mattered. They mattered significantly, but they mattered less than industrial capacity when wars lasted years and when losses had to be continuously replaced. Japan had courageous sailors, well-trained pilots, and excellent tactical doctrine. Japan lost because they could not build carriers fast enough. America won because they could. That brutal truth reshaped naval warfare permanently. The age of the battleship had ended at Pearl Harbor. The age of the carrier began at Midway. But the Battle of the Philippine Sea and the subsequent destruction of Japanese naval aviation proved something more fundamental. Modern naval warfare was industrial warfare. The nation that could build more ships, train more pilots, produce more aircraft, and sustain operations longer would win. Quality still mattered. Numbers mattered more. In the decades after the war, historians debated whether Japan could have won with better strategy. Could they have avoided Midway? Could they have preserved their carriers? Could they have trained pilots faster? The consensus that emerged was no. Not because Japanese strategy was flawed, though it was, but because the industrial disparity was insurmountable. America entered the war with 10 times Japan's industrial capacity and a plan to use that capacity for carrier construction. Japan entered the war with a plan that assumed America would not fully mobilize that capacity. The assumption was wrong. Once America committed to building carriers at maximum capacity, Japan's defeat became inevitable. The only question was how long it would take. The men who fought the carrier war understood this before the historians did. American carrier pilots in 1944 knew they were winning not because they were better pilots, though many were, but because they had more carriers, more aircraft, more fuel, more replacement pilots. Japanese carrier pilots in 1944 knew they were losing not because they lacked courage, though some did, but because they were outnumbered, outproduced, and outsustained. The mathematics were visible to anyone who looked. Ensign Sakae Yamamoto had seen it in a classified briefing 3 days before he died. 15 American carriers against 9 Japanese carriers. The disparity would only grow worse. He understood what that meant, even if his commanders would not admit it. The war was over. Japan had lost. They just had to keep fighting until America finished winning. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.